Hello folks, welcome to the second tutorial session on HYSYS. In this video tutorial we will simulate the manufacturing of ethyl chloride from ethylene and HCl, and we will use HYSYS as the process simulator in this particular case. Alright, the process, as you can see, looks pretty simple. It involves the reaction of ethylene with HCl to give you ethyl chloride. So as far as chemistry is concerned, yes, it's pretty simple, but when this translates into a full scale plant operation, it's pretty difficult and it's pretty complicated, I can tell you. Alright, so without wasting time, let's go to the problem at hand. In this particular case, the feed stream comprises of mixture of ethylene and HCl, and it has nitrogen as well. The total feed flow rate is given to you as 100 kg mole per hour, and the feed composition is 50 mole percent of HCl, 48 mole percent of ethylene, and 2 mole percent of nitrogen. The feed temperature and pressure here are given to you as 25 degrees centigrade and 1 atmospheric pressure. You're further told that the ethylene conversion is 90% in the reactor. Just a little bit about the process, although it's pretty simple. As you can see, the process involves a catalytic reactor where ethylene reacts with HCl to form ethyl chloride. The product is then separated in a separator or a component splitter, wherein the bottom product is pure ethyl chloride, whereas the top product is the unreacted component together with inerts. Since as inerts were, as you can see, the feed stream itself has inerts to start with, so a purge is taken out from the top product to prevent the accumulation of inerts in the system. Alright, so in another couple of minutes we'll switch to the HYSYS window. If you have HYSYS installed in your system, you just need to go to the start button, look for the HYSYS the program, and just click on the button, and a window similar to this would open up. Alright, so now because you're starting a fresh simulation, so what you now need to do is go to the file command and select new, and then select case. Alternatively, you could just click on this button and a simulation basic manager window would open up, as you can see on your screen. What is particular about HYSYS, and is peculiar about HYSYS, is that it wouldn't let you enter the simulation environment until you provide information about the components that you would be using in your reaction in your simulation, and additionally it wants you to tell upfront the fluid package that you would be using, and you may also have to supply information about the reaction, if any, in the simulation. Alright, so we'll go ahead with the component list. To add the components, click on the add button and then look for the components of interest. In this particular case, we are worried about ethylene, so we will type in ethylene, but we are not getting it, so we can search using the formula. If you want to, you just need to type C2H4, and there you go. On the very first hit itself you get ethylene. Alright, so this is what we were looking for. Alright, just click on add pure, this gets added up. Then look for nitrogen, press enter, and it gets added up. HCl gets and added up. Alright, so these are the three components of interest in this particular case. Now what you need to do is close this, go to the fluid package, add the fluid packages that you want to use. In this case we would be using the popular Penn-Robinson equation, which is here. Alright, so this is fine. Next, what you need to do is close this. Now we are all set. As you can see, the current fluid package, this window shows the basis, the number of components in this particular simulation, and the thermodynamic equation of state that you are using, which is Penn-Robinson. Alright, so now you're ready to enter the simulation window. So press this button and the PFD screen would pop up along with this PFD palette. Alright, so okay, fine. So before we proceed further, we'll first put down all the process equipment or the unit operations that we would be using in this particular simulation, we would need a mixer to mix the ethylene stream and the HCl stream. And how do we do that? Okay, so where is the mixer? There is the mixer. This is the mixer. Okay, so we take the mixer stream here. All right, so this is one thing. Now we need a catalytic reactor where conversion reaction is taking place. The general icon for reactors is this is not the general icon for the reactors. Where is it? All right. Okay, now from here you can see there are three different kinds of reactors. First is the Gibbs reactor, the equilibrium reactor, and a conversion reactor. For our case, we need to select the conversion reactor, so bring it down here. Next, what we need is a component splitter, which you would find somewhere here. Okay, this is the component splitter. Put it here. Next, what we need is that's all. All right, so these are the three things we need. We need to connect the recycle stream back to the feed stream and then feed it back. All right, so in order to connect these equipment, you need to select the material stream from here. And okay, fine, the scheme with HYSYS is slightly different from Aspen and Pro 2. Unlike Aspen and Pro 2, you don't really connect streams like this. So what you do is that just delete this for a second, click again on the material stream, just click it here, then click on the mixer, give it a name if you want to give, put stream 1 as the inlet to the this mixer. All right, the outlet you can select it as, let's say, stream 2. All right, so you have done this. Note that the recycle stream that would emerge from the component splitter will come back and mix here, that we will see shortly. Now click on the catalytic reactor. The feed is S2. Let's say we are talking about only the vapor stream, which is, let's say, make it S3. There is no liquid bottom product from this reactor. Okay, the reaction is exothermic in nature, so this would involve some energy withdrawal. All right, is this fine? So we do this. Next, what we do is that this is fed to this component splitter. The feed to the component splitter is S3. The overhead stream, let's say, make it as S4, and the bottom one, let's say, make it as S5. All right, is this fine? Okay, so now we know this, so we can close this. We have not specified any other data. It's just a PFD that we are drawing right now. All right, you can just clean it up a little. You can just drag the streams a little farther away, make them look good. Now what we need is a recycle unit. So here is the recycle unit. What you can now do is click on the recycle button. The inlet to this is S4. The outlet is, let's say, S6. Right, we have not solved this, we have just connected. And let's say to the mixer head, the second inlet is S6. All right, and then we connect it here. So the entire scheme of this reaction will give you a PFD which looks like as you can see on your screen. All right, I hope we have not missed out anything. Note that we have not specified any data right now. Right, all that we have done is simply drawn the PFD. All right, if you want to name these streams, or if you want to give any particular name to these streams, feel free to do so. You can click on this and then choose the option, renaming and all those things, formatting. Right, is this fine? Okay, so the first stage of the scheme, entire this simulation, is to set up the simulation window. We'll just stop here for a few seconds and then start with the second part of it. All right.